Factorization by remainder theorem. Let's use remainder theorem to factorize the polynomial x cubed plus 8x squared plus 19x plus 12. We are going to take a look on the highest degree term, which is x cubed, and let us name its coefficient as p. So p is coefficient of the highest degree term, which is x cubed, and its coefficient is 1. And we also want to take a look at the lowest degree term, which is constant, and let's name it as q, and this is equal to 12. This is important to identify the coefficient of highest degree term and the last term, mean the constant term, and write down all factors of q. Write down all factors of q, and here we are going to write down all factors. Write down all factors of p. So what are all factors of q? 12 has factor plus minus 1, it has factor plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. These are all the factors of q, the constant term, the very last term in the polynomial. And now let's take a look at all the possible factors of p, which is 1. So its only possible factors are plus minus 1. Now take all the ratios r of r equal to plus minus q over plus minus p. So now because p is equal to plus minus 1, so the only numbers that those are going to come is the factors of q: plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. Now these are all possible numbers which could possibly be factors of the given polynomial. I mean the roots of the given polynomial. And we are going to test each one of them using remainder theorem, and will isolate those numbers for which p of r is equal to 0. Let's test p of 1. P of 1, that's just in the given polynomial, replace x with 1. So this will give us p of 1 equal to 1 cube, replacing x with 1. So this would give us 1 cube plus 8 1 square plus 19 times 1 plus 12. Obviously all the terms are positive. It's not going to be equal to 0. We have 1, then we have 8 times 1, 8, plus 19 plus 12. We are really not concerned with what it is. We are only interested if it is equal to 0 or not. Obviously this is not equal to 0 because all the terms are positive and their sum is going to be lot more than 0. So our conclusion is, so x equal to 1 is not the root of given polynomial. Now we know that 1 is not the root. Let's try minus 1. P of minus 1. Again do the same thing. In the given polynomial, replace x with minus 1. It's simply evaluating an expression which we have learned at the start of algebra. So this would be minus 1 cube plus 8 times minus 1 square plus 19 times minus 1 plus 12, and let's simplify and see, is equal to minus 1 power odd. The answer is always negative. This would be minus 1. Negative 1 power even, answer is positive, so this is plus 8. This is minus 19, that is plus 12. And now let's collect all the negative terms. Minus 1 and minus 19 was going to be minus 20. Plus 8 and plus 12 is going to be plus 20. And we have 0. Way to go. We got 0. Therefore x equal to minus 1 is root of the polynomial, and if x equal to minus 1 is root of polynomial, then x plus 1 is factor of given polynomial. Similarly, we are going to use hit and trial method, just guessing work, and we will try other numbers, but out of the numbers we already have identified as R, these numbers here. And out of these numbers, 3 of them are going to be factors of the polynomial, because the degree of the polynomial is 3 and it must have 3 roots. For next, we are going to try minus 3. So p of minus 3, let's calculate p of minus 3, and similarly replace x with minus 3. This is going to be minus 3 power cube plus 8 time minus 3 square plus 19 time minus 3 plus 12, and this is going to give us minus 3 power 3. On calculation, it's going to give us minus 27, and plus 8 time 9 minus 19 times 3 is going to be 57 plus 12, and let's add all the positive numbers. And this is minus 27 plus 72 minus 57 plus 12, and here negative numbers are minus 27 and minus 57. The answer is minus 84, and 72 plus 12, which are positive, answer is plus 84, and answer is again equal to 0. So x equal to minus 3 is another root, and x plus 3 is factor of p of x. So far we have found out 2 factors. There is one more factor, and without wasting any time, the only number which is going to satisfy out of these many numbers is minus 4, p of minus 4, and let's do that. Minus 4 power 3 plus 8 time minus 4 square plus 19 time minus 4 plus 12, and this is equal to minus 64 plus 8 time 16 minus 6 and 7 plus 12, and now let's add the positive and negative number, and it must be equal to 0. Therefore we have, so we can say that, so x equal to minus 4 is root hence x plus 4 is factor of px. You can try all the other numbers. None of the other number is going to give you the value 0 whenever you substitute that number into the polynomial. Therefore, we have collected which are the factors. X plus 4 is one factor, and we had x plus 3 was another factor, and x plus 1 was another factor. And when we multiply all these factors, this must be equal to p of x. This means that the given polynomial x cube plus 8x square plus 19x plus 12 is in factorized form equal to x plus 4 into x plus 3 into x plus 1. This is how we can factorize the given polynomials using remainder theorem. Let's do one more question, and here example: find factors of the given polynomial p of x equal to x cube minus 7x plus 6. Solution. Here the leading coefficient is 1, so we are going to take a look on, okay, we have p, which is the leading coefficient. Write down p is equal to 1, and what is q? Q is equal to 6, and factors of p are only plus minus 1, and factors of q are plus minus 1, plus minus 2, all those numbers which divide 6 evenly, plus minus 3 and plus minus 6. Therefore, the ratios are all the values of q over p plus minus q over plus minus p, which are, because p is equal to 1, therefore only values of q are the possible ratios. So plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Now our roots of the given polynomial are among these numbers. It's either plus 1 or minus 1 or plus 2 or minus 2, plus 3 or minus 3, or plus 6 or minus 6. So we are going to try, as usual, p of 1. So let's try p of 1 and evaluate the expression at x equal to 1, substituting the value of 1 for x. So here it gives 1 cube minus 7 times 1 plus 6. So 1 minus 7 plus 6. 6 plus 1 is 7. 7 minus 7 is equal to 0. So x equal to 1 is root, and x minus 1 is factor. So we have got one factor. Let's try to find another one. Similarly, let's try p of x equal to 2 now, and that would be 2 cube minus 7 times 2 plus 6, and 2 cube is 8 minus 14 plus 6, and this is 14 minus 14, which is equal to 0. So x equal to 2 is root of px, which means, and x minus 2 is factor of px. So we have found another factor. As the polynomial is of third degree, one more is going to be the factor, and I believe that's going to be number minus 3. So let's try minus 3 here. P of minus 3 is equal to minus 3 power 3 minus 7 time minus 3 plus 6, and minus 3 power 3 is minus 27 plus 21 plus 6, and here's the answer, minus 27 plus 27. The answer is 0. So out of all those numbers, these are the only numbers. This means x equal to minus 3 is root. Therefore x plus 3 is factor. So we have found all the factors. Hence the factorized form of the polynomial would become x cube minus 7x plus 6, and write down the product of all factors that must give us the same polynomial. So x minus 1 times x minus 2, x minus 2 times x plus 3. So these were, so x plus 3 is here, x minus 2 is here, and x minus 1 is right here. So therefore all these were the factors which we have multiplied in order to get the required polynomial. Here is one last example. Just I want to make sure that you solve a question where p is not equal to 1. That's why we have this question. So now the polynomial is p of y is equal to 6y cube minus 13y square plus 4. And now what is p here? P is the coefficient of highest degree term, which is y cube, and its coefficient is 6. So p is equal to 6. And what is q? Q is the constant term, which is equal to 4. So factors of q are plus minus 1 plus minus 2 plus minus 4, and factors of p are plus minus 1 plus minus 2 plus minus 3 and plus minus 6. Now we want the ratios are now possible roots. Possible roots are all the values of plus minus q over plus minus values of p, which are equal to plus minus 1 plus minus 2 plus minus 4. And now all the values of q must be again divided by 2 and then by 3 and then by 6. So if we divide by plus minus 2, those will become plus minus 1 over 2 plus minus 2 over 2 is going to be plus minus 1, which already we have here. So we don't need to, and plus minus 4 divided by plus minus 2 is going to be plus minus 2, which we already have here. Now plus minus 1 over 3, that's another possible value, plus minus 2 over 3, and similarly plus minus 4 over 3. And now the last number 6, this is going to be plus minus 1 over 6, plus minus 2 over 6 is going to end up plus minus 1 over 3. We already have it here. And plus minus 4 over 6 is going to be plus minus 2 over 3, which we already have here. So these are all possible values for the roots of the given polynomial. Here we have 1, 2, 3, 4, 5, 6, 7, 8. 8 and 2 times is 16. Possible 16 roots you are supposed to test. And only how many of them are going to give us the value 0 for the given polynomial? Only 3 of them. So this is quite a guessing game. Let's start with x is equal to 1. So p of y is equal to 1. Let's try it. P of 1 is equal to 6 times 1 power 3 minus 13 times 1 square plus 4, and that is equal to 6 minus 13 plus 4, and whatever it is, it's 6 plus 4 is 10 minus 13, answer is equal to minus 3, and definitely this is not equal to 0. So x equal to 1 is not the root, and if x equal to 1 is not the root, then x minus 1 is not the factor. Let's try 2. P of 2. This is equal to 6 times 2 power 3 minus 13 times 2 power 2 plus 4, and this will give us 6 times 2 power 3 is going to give us 8 minus 13 times 2 power 2 is going to give us 4 plus 4, and this is 48 minus 2 and 52 plus 4, and we can see here that 48 plus 4 is 52 minus 52, that is going to give us 0. So x equal to y equal to 2 is root for py, and now if y is equal to 2 is root, then y minus 2 is factor of py, and similarly let's test minus 1 by 2. P of minus 1 by 2, P of minus 1 by 2 is equal to 6 times minus 1 by 2 power 3 minus 13 times minus 1 by 2 power 2 plus 4, and this will give us 6 times minus 1 over 8. This will give us minus 13 times 1 over 4 plus 4, and this will give us minus 2 equivalently will go. 2 3 times is 6 and 2 4 times, so this will give us minus 3 over 4 minus 13 over 4 plus 4, and if we simplify minus 3 by 4 plus 4, that will give us 4 minus 3 plus 16, that will give us plus 13 over 4. So this is plus 13 over 4 minus 13 over 4. This gives the answer 0. So x equal to minus 1 by 2 is root of py, and p of this is y because the variable given is y plus 1 by 2 is factor. And now we are going to look for the last factor, and that last factor is plus 2 over 3. So let's try p of 2 over 3 here, and that would give 6 into 2 over 3 power 3 minus 13 times 2 over 3 power 2 plus 4. It ultimately, if you make calculations, the answer is going to be 0. So that on calculations, this is going to give us 0. So y equal to 2 over 3 is root, hence y plus 2 over 3, y minus 2 over 3 is factor. So of py, and if we have found out all the factors, then p of y is equal to y minus 2 into y plus 1 over 2 into y minus 2 over 3. These are all the factors. This means that 6y cube minus 13 y square plus 4 in factorized form is equal to y minus 2, y plus 1 over 2 to y minus 2 over 3. So this was one of the technique which we use for polynomials in one variable, and with a degree it can go to whatever level it can go, like 3 or 4 or 5. But this requires some time, it requires a lot of work, and we will ultimately learn a technique called synthetic division, which will make things simple for us. See you in next video.